Ever felt the ground shake and wondered what on earth is happening down there? Earthquakes can feel totally random, right? Terrifying even. But what if I told you they're not random at all? In fact, they're a sign that our planet is incredibly active and alive. We're going to uncover the powerful physics behind it all. So let's just start right at the beginning. What really is an earthquake? Sure, it feels like pure destruction, but what's actually happening is the Earth's giant puzzle pieces are, well, they're grinding past each other, trying to settle into a better spot. It's like a violent planetary sigh of relief. To really get this, I want you to hold one simple image in your mind for this whole explainer. Just picture our planet as a giant, fragile eggshell that's already cracked all over. Seriously, that one idea? It's the key to understanding everything else. Now, that eggshell idea isn't just some cute metaphor. Our planet really is broken up into these massive, continent-sized chunks. So let's take a closer look at these pieces and see how their constant, slow-motion dance literally shapes our world. These pieces are called tectonic plates, and they are enormous slabs of rock that are always, and I mean always moving, about as fast as your fingernails grow. Now, I know that doesn't sound like much, but when we're talking about a piece of rock the size of North America, that slow, relentless crawl packs an unbelievable amount of power. And here's where the trouble really starts. These plates don't just slide past each other smoothly. Nope, their edges are jagged, and they get snagged and locked together. But the forces pushing them don't stop, so pressure just builds and builds and builds, sometimes for decades, even centuries, until finally the strain is just too much. And with a sudden, violent jolt, they snap. That snap, that is the earthquake. But what is actually happening during that snap? It's not just rock breaking. There's some really cool physics going on that stores up all that energy, kind of like a coiled spring. Let's dig into how that works. To get this, all you need to do is picture bending a stick. You've done this, right? You apply pressure, the stick starts to bend, it resists you, you push harder, it bends even more, and all of that energy you're putting into it is getting stored inside the wood. And then, finally, snap. And believe it or not, that simple idea of a stick breaking has a proper scientific name. It's called the elastic rebound theory. It tells us that rocks along a fault line don't just shatter. They actually bend, they stretch. They store that immense pressure elastically, just like a spring being compressed, waiting to be released. So you can think of it like this 4-act play that's happening deep beneath our feet all the time. Act 1, the plates get stuck. Act 2, the rock itself starts to bend and deform, storing up insane amounts of energy. Act 3, the stress finally becomes greater than the rock's own strength. And for the finale, the rock breaks, snapping back into place and unleashing all that stored energy in a massive shockwave. Okay, so the rock snaps and releases a phenomenal amount of energy. But how does that energy get from deep inside the Earth all the way up to the surface to shake an entire city? It travels in waves. The best way to think about it is like dropping a huge boulder into a perfectly still pond. It sends out these powerful ripples of energy in every direction. We call these seismic waves, and they are the reason the ground physically shakes beneath our feet. And get this, not all of these waves are the same. First, you get the P waves. They're the fastest, and they feel like a sharp, sudden jolt like a punch from below. Right after that come the S waves, which move side to side. That's the real shaking you feel. But here's the crazy part. The most destructive waves are actually the slowest. They're called surface waves, and they roll along the ground like waves on the ocean. They're the ones that make buildings sway and crumble. Now, when you hear about where an earthquake happened, it's really important to know these two terms. The focus, sometimes called the hypocenter, is the actual spot deep inside the Earth where the snap happened. But the epicenter, that's the point on the map, on the surface, directly above the focus. It's basically the X marks your spot for all that energy. And that matters a whole lot because the epicenter is ground zero. It's the place on the surface that's closest to that huge energy release, which is why the shaking and the damage is almost always the worst right there. So how do we actually measure how big an earthquake is? You hear those numbers on the news all the time, right? A magnitude 7.2. But what does that number really mean? Well, we actually use two completely different ways to measure them, and they tell us very different things. It really just boils down to cause versus effect. Magnitude measures the cause, the raw energy that was released at the source, way down deep. Intensity, on the other hand, measures the effect, the damage and shaking that we actually feel up here on the surface. So you could have a huge magnitude quake in the middle of the ocean that has almost zero intensity for people on land. And that magnitude scale, it is seriously deceptive.
Because it's a logarithmic scale, every single whole number you go up, the energy released increases by about 32 times. So a magnitude 7 isn't just a little bigger than a 6. No way. It's a completely different beast. The difference in power is just immense.
All of this immense energy has very real and often very dangerous consequences for us. Understanding the science is one thing, but it's so important to remember why all of this really matters.
Well, the most obvious dangers are things like buildings collapsing, but the chain reactions can be just as deadly. Earthquakes can trigger gigantic tsunamis, they can shake hillsides loose and cause massive landslides. And they can cause this bizarre thing called soil liquefaction. It's where the intense shaking literally turns solid ground into a soupy, quicksand-like mess, causing buildings to just sink or fall over.
So when you put it all together, from the cracked eggshell of our planet to that snapping stick, you see the big picture. Earthquakes might feel chaotic and random, but they are not. They are the predictable, inevitable result of a planet that is always moving, always changing. It's just a sign of a living world.
In the end, it all comes down to this one powerful thought. An earthquake is just the Earth releasing stress. Stress that it's been silently building for years, all in the space of just a few seconds.